exercises keep like connecting with the previous one. The previous one, what we learned is talk about the approximation area under the curve. Okay, so we're trying to approximate the area by using left-hand side rectangles or right-hand side rectangles. So what we have done is we sketch rectangles there, and we use the rectangles area to say this is the approximation area for the area under the curve. But we can see we have more, okay, overestimate on the right-hand side, but we have underestimate on the left-hand side. The more triangles we're trying to sketch, the more accurate result we will receive. Okay, so what's the ideal, like how many rectangles is the, let's say, not say how many. If I make 100, that's better than 50. If I make 1,000, that's better than 100. So the more the better. So what's the largest number we can have? Well, it's not really a number, but it's infinitely many rectangles. They're really, really, really tiny rectangles. It's almost just a line. And then we have infinitely many lines over that area. We treat that as the actual rectangle, like the actual area, okay, the actual area. So last exercise just tells us it's not very accurate by using just like 5 or 4 rectangles. We can see whether it's underestimation or overestimation. But if we can sketch more rectangles, that will be really good, and we can treat this exactly the same area, okay, exactly the same area as the area under the curve. So last lesson I have to go through a formula. I said this formula will be quick if you can have your calculator and you just type that in. Depends on whether it's a left-hand side rectangle or right-hand side rectangle. So you don't need to understand why it's hard to explain. Well, it's not hard. I just don't want to go through that a lot. It's not really necessary. But if you can just write that down, if it's a cat section, you will have your notes as well, and you can just type that in, and that's really easy to get the result. But this sign means sum, okay? So it means you're adding things. So you're adding things from k equals to 0 to k equals to -1. Let's say n minus 1 equals to 5. So what's the value I can take for k? So this formula means k from 0 to 5. For example, if I'm writing that. So k equals to 0 to k equals to 5. But k can only take integers if you use this sign. So k only take 0, 1, 2, 3, 4, 5, like those 6 numbers. But if you want to do, well, now what I want to sum is k is infinite many numbers. Like we want to take all the values, like k can be really, really, really tiny values. Well, the k we have represent like you add 1 step size, 2 step size, 3 step size. This is only sum for countable numbers like 0 to 5 and only integer. There's a sign used to sum infinite many numbers, which we use this sign. That's how we have this integral here. So they are basically the same thing. They all means like the sum of things, like the sum of something. But this means the sum of all the infinite many things in between A and B. But for this sign we use, it's only the sum for 0, 1, 2, 3, 4, 5. Like we only take countable numbers for that one. So that's the difference. They are basically the same thing, but it all means sum of things. But one is some countable numbers, one is some countless numbers. So you don't need to understand like more than that, okay? You don't need to understand more than that, but like that's how, like that's why, if you really want to know why, like in uni you will learn more, but that's infinite many sum. So now you know if I want to find the area in between, if I have a curve like this, okay, so we want the area in between A and B. Like I want this area. You know that I want infinitely many rectangles there. So what we can do is the exact way. It's very hard to tell you now like how this formula come from the previous page to this page, but like I think you just remember the basic idea is it's a sum as well. Okay, it's a sum as well. So how do we calculate the actual area? The actual area is the integral for the fx function. So we use this integral now is nothing related to f dash x to fx. It's another meaning. This is the other meaning of the integral. So for integral, we can go for f dash x back to fx. Okay, or we can talk about fx area under the curve. Okay, so there are two meanings of it. Well, one is you can change f dash x back to fx, and the other one is we want to find the area of the fx graph. Okay, you have your original function there. There is just a function. You integral that function in between 2 points. Okay, I'll talk about how to calculate in between 2 points. But you integral the function and you have one point to another point. Let's talk about the area under the curve. Okay, so that's totally two separate things. Okay, there's no connection between f dash x and fx and the area under the curve. So one function it can be used is from derivative function, it can back to fx function. The other meaning is just like the area under the curve. For fx function, we integral that, we put two numbers there, and which means the area under the curve between that 2 points. Okay, that's the second meaning we learned for this exercise. Okay, so how do we evaluate that? This is called a definite integral. Remember last time we talked about indefinite integral, but this time we talk about the definite integral. This is like with in between a and b, so just for that integral. Okay, so this is called a definite integral. So how do we evaluate? Like, what's the connection between the previous exercise and this exercise? It's very easy to do calculations. fx, right? fx, we integral fx and put a and b. We just anti-diff it anyway as normal as last time. Okay, we anti-diff it. We just anti-diff it. We'll achieve a function fx. Similar to f dash x back to fx. So we anti-diff the function anyway. And now we put a to b. Okay, we put, so I will do an example here. So for example, this means under that function, I want the value in between 0 to 1. Okay, under that function, I want the value in between 0 to 1, that area. So I can sketch the graph, I can sketch 0 to 1, and I can shade the area. Okay, so what I will do is I will ignore the 0 to 1 first. I will just anti-diff it anyway as what I did before. So this will equals to 6x minus 4x squared over 2 plus 3x to the power 4 over 4. Okay, still anti-diff that, but I don't plus c now. Because this is not an indefinite integral, this is a definite one, I don't need to plus c when we have the numbers there. So what's the next step I will do is, I will put a square bracket, and I'll put 0, 1 there. Yeah, and I'll put 0, 1 there. So it means x equals to 0 and x equals to 1. This represents the x value. X equals to 0, x equals to 1. So that anti-diff that, and I put 0 to 1 there. And the next step I will do is I sub the top number first. Okay, doesn't matter which number is larger, which number is smaller. So for example, I can go for 4 to 3. I'll explain what 4 to 3 means later. Like, the order is important, but doesn't matter which one is larger, you always sub the top number first. Okay, which one on top, you sub that one first. So we will sub 1 into the function first. Okay, so we sub 1 into the function, we got 6 minus, that's a 2, and plus a 3 over 4. Okay, we bracket that. That's when we sub 1 into the function. And now I will sub the bottom function. Okay, I will sub the bottom number into the function. So I will sub 0 in, but you can see that's 0 minus 0 plus 0. But it's not always 0. If you have negative 1 there, that won't be 0. So just sub 0 in. And now what you do is you put a minus in between. You sub the first number in, you sub the second number in, and you minus the two results. The result you have now, that will be the area under the curve. Okay, that will be the area under the curve. So that's a 4 plus 3 over 4. That's a 16 over 4 plus 3 over 4. And that's a 19 over 4. This is just the evaluation. I just want to show you when you want to evaluate it. That's just one more step compared to the normal antidiff. Even though the meaning is totally different, but the rule is still the same. Okay, we still antidiff it, and we just sub the first number and minus the result, you sub the second number. Okay, so that's for evaluation. But, okay, let's see, there are just examples here. Okay, but when we use this, well, all the examples I give you before is talk about the area above the curve. Remember that? It's all talk about the area above the curve. I never show you when I talk about the area under the curve. But if I draw this, okay, something like that. Well, you can draw any curve with up and down. Okay, so now I want to talk about the area in between A and B. Okay, I want to talk about that. Okay, some above and some below. So the area I'm talk about is this area. Like this is the area under the curve. Like rather say under the curve, I would say is the curve made with x-axis. Okay, the area bound between the curve and the x-axis. So it will be that area. So what I will do is, if I say this area, like the size is A1, this area the size is A2. Okay, let's say this coordinate is C. Okay, that point is a C. When we do integral a to b fx dx, okay, when I say, because it's the point from a to b and talk about the area between the x-axis and the curve, I will just put a to b, like the smaller to the larger number. This area you calculate out will be negative, because you can see this is more like larger area and this is a smaller area. When we're using this formula already involves positive area and negative area. It's not going to be a total area. It's just like the top one minus the bottom one. Okay, it's the signed area. When you use integral, this will give you the signed area instead of the total area. That will be the area of the top minus the area of the bottom, not area of top plus the area of the bottom. So this one will be a number less than 0, because you can see from the graph I sketched, A2 is larger. So it will be a negative area. Okay, it will be a negative area. So just want to let you know, when you use the integral, that is the signed area when you calculate. But let's think about that. In some particular case, yes, I need the signed area. For example, if I want to talk about the displacement and the VT graph, I want to talk about the signed area to calculate the displacement. But I also need the total area. For example, the VT graph, I want to talk about the total distance. Then I need the total area, not the signed area. So in different situations, we need different area. Like sometimes we need signed. Well, when I need signed area, will be talk about displacement only. That's the situation I can think about. But most of the time, I will interest in a total area. Okay, in a total area. So, well, why I ask you, what's the area show you on the graph? And if you just show me that thing, it doesn't make much sense, because it's not going to give me this area plus this area. So something you need to do is you need to separately calculate them. Okay, you need to separately calculate them. So a total area can be calculated by integral from a to c of fx dx. That will definitely give me a positive area. Okay, that will definitely give me a positive area. And then I will minus the area from c to b of fx of dx. Because you know, when you do this, this will give me a negative number. And I minus this negative number, that's just plus the bottom area. In this case, I can have a total area rather than a signed area. And most of the time, I need a total area. Like, I want to know what's the area show me now. I don't care like what's the top minus the bottom. Like, it doesn't make any sense to me. Like I can't get any information from that. I want the total area instead of the assigned area. You need to use the top minus the bottom area. Okay, so from C to B, you will calculate out a negative area because that area is below the x-axis. And now we minus the negative area, you still make it positive, and it's adding. Okay, it's the two area adding. So in this case, you will have A1 plus A2. Okay, you have A1 plus A2. Okay, so basically that's what the summary talk about. Okay, what's the summary talk about? If it's above x-axis, you just calculate as normal. If it's below the x-axis, you want to know the total area, you need to negative that area to gain a positive. Okay, to gain a positive. But when you see things giving you like this, okay, just give you 4 cos 2x over 3 from pi over 2 to 3 pi over 4. Let's just talk about the signed area. Okay, because things is already given to you, is talk about the signed area. But it can be a total area as well if it's everything above the x-axis in between that domain. If some part is below the domain, the area will be less. Okay, the area will be less because you will minus the bottom one. So I have 1, 2, 3 questions here. I want you to calculate. Well, it's still just ask you to additive things. Okay, just a little bit reminder how to do all these rules because we haven't learned that for 5 days already. So I want you to try those 3 questions. I'll give you, let's say, 15 minutes because after that I need to talk about a little bit more properties. So I'll give you 15 minutes. 10 o'clock I will start like checking answers with you for those three questions, and now I need to keep moving to those properties as well. Okay, for circular function, I still feel like this is the weakness for like most of you to do the antidiff. Like you're confused about antidiff of cosine is what, antidiff sine is what. If you really you can't remember, you can remember the diff and then you say is the opposite way of diff. So if diff have sine to cosine, then sine will be negative cosine for antidiff. So that's how another way you can remember that. But anyway, when you have 4 cosine 2x plus 2x over 3, we can go, that's a 4 times 3 over 2, 1 over a, times cos will go positive sine, and that's 2. I will say 2 over 3x. I don't like to put x together with the coefficient. And I don't need to plus c because it's a definite integral. And I have pi over 2 to 3 pi over 4. So what I have here is a 6 sine 2 over 3 times x, pi over 2 to 3 pi over 4. Well, you can get the 6 outside the bracket because it's 6 loss of that sign minus 6 loss of another sign, and you can take 6 as a common factor. But like you can just make the 6 involved to calculate. So when I sub the first number in, that's sine 2 over 3 times 3 pi over 4 minus the second substitution, 6 sine 2 over 3 times pi over 2. Okay, that's the 2 subtraction. Top one minus the bottom one. So that's a 6 sine pi over 2 minus sine pi over 3. Okay, sine pi over 2 is 1. Sine pi over 3 is root 3 over 2. And that's 6 minus 3 root 3. Okay, 6 minus 3 root 3. I have a suggestion for you. I know you already have the table on the circular function notes, but if you forget like how to do the exact values, do not try to go back to the notes and copy the answer down, because by that way you never remember things. So you know the way I tell you, like the table, root 1 over 2, root 2 over 2, root 3 over 2, and then backwards, root 3 over 2, root 2 over 2, root 1 over 2, and the last line is 1 over root 3, 1 and root 3. So write the table down again by yourself, just besides what you have. I don't mind if you just want to work out one values. Set up the table, write the table again. It won't take you more than 15 seconds. So by that way, you can always remember, you get the fluency, okay? So otherwise, if you don't do that, you just go back to check the answer, put that in the calculator, you never remember things, okay? If you want to remember things, that's through practice. Just don't stare at the questions, or don't just go back to find the answers from somewhere you already have it. So that's another way you can practice and how to remember trig values. I know it's hard, that's why I tell about like a lot of ways how to remember that, okay? So for that one, the area will be 6 minus 3 root 3. Okay. Next one. Next one, the power is minus a half. So 1 over minus a half is 2. Minus 2. So you have minus 6e minus a half x. And plus 4 over 3e to the power of 3x. And you put negative 2 to 2. Minus 6e, we sub 2 into the function first. What we have is minus 1 here, plus 4 over 3, e, you sub 2e, you have 6. But that's the first function, okay, that's the first substitution. And then your second substitution, you might, what color changed? You minus the second substitution. The second substitution, when you sub negative 2 in, you have minus 6e1. Okay, negative 2 times negative half, that's 1. Plus 4 over 3 e to the power of negative 6. And now I can expand. That's minus 6 over e plus 4 over 3e to the power of 6 plus 6e and plus 4 over 3e to the power of 6. And you can see I can't really combine anything. Minus, sorry, that's a minus. Okay, open the bracket. That's why you need that in the bracket. When you open bracket, that's a minus. So plus e, 6e, and minus that. And you can see I can't simplify that. Well, we can just leave the answer like that. We can do something, for example, make to the same denominator, but like make even complex. So I don't want to do that. If you want approximation area, type that in the calculator and you have the approximation area. I'll tell you how to use calculators next lesson. Okay, next lesson. Okay, last one. Well, is constant over a linear, definitely log. Okay, definitely log. So that's a 3 over 4 log e absolute 4x plus 7. And the value L sub is negative 1 to 3. So 3 over 4 log e, we put 3 in, that's a 12 plus 7 is a 19. Minus 3 over 4 log e, we put negative 1 in, I have the 3. Well, like, I should have absolute sign here. Okay, I should have absolute sign here because I sub things in. But because absolute sign is only change negative to positive, but the number I have here is already positive. There's no difference between absolute value sign or like just a round bracket. So I can just change it to a round bracket. Okay, there's no difference, but I can just combine that. Okay, I can just do that. Because absolute and positive is the same as just number, is that number itself. And if you know the rule for log, I can just combine that. Okay, so 19 over 3. So minus log is the divide. Okay, it's the divide. Yeah? You don't need to write that. Yeah, but like in this step you must write it. Because this is unknown, it depends on your x value. But next step, when you substitute, is positive, you can just get rid of it directly. It just changed to positive. you get rid of that. So if say it's -2, then that's a 2. Any questions for these 4 evaluations? Yes? Well, if it's different constant, you can put the as a power back, and you can still divide it. But like, it's not really necessary unless it asks you a particular form. If they say put this in m log en form, then you must put in 1 log. Otherwise, you can leave it as 2 log. There's nothing wrong with that answer. Say it's different, like 1 is 2, 1 is 3. I can just put as a power of 2 and power of 3, and then still divide that 2 numbers. Questions? Okay, if we don't have questions, I want to talk about some properties. Okay, first property is if we have 2 lower limit and upper limit is the same number, say integral of 1 to 1 for fx dx, that is just a 0. Very easy to understand because the area is 0. 1 to 1 is a line. Okay, there's no area create from 1 to 1. So I need 1 to 2 to create an area, but like 1 to 1 is a linear, it's a line. Okay, so it's just like this. Okay, that's A to A. So there's no area, so that's why the area equals to 0. So that's the first one. Okay, the second one. Second one, if the graph of symmetrical about y-axis, then if you have 2 symmetrical points, that's 2 lots of 0 to A. So example is, if you have an even, this is, okay, symmetrical about y-axis, this is even function already. Okay, last year VCAR exam, 2017 VCAR exam. I will show you an example tomorrow. I don't have the example. I need to find it online. I don't have time today. I'll show you this example tomorrow. It's a really good question combined with even function. Last year, it's very low percentage of students get that right. So I'll show you that next lesson. But say we have an even function like this. Okay, well, I know it's not very even, but we treat it as an even function. We say we have a point A to A. Okay, we want this area. But because it's even function, that's just cut, like the y-axis is cut into half. Okay, let's say we want -2 to 2. Because it's symmetrical point, and from 0 to 2 and -2 to 0, they are the same area. So the integral, well, originally I should have -2 to 2 of fx dx. And that will equals to 2 lots of 0 to 2 of fx dx. Or I can say it's -2 to 0 fx dx. But why I put 0 to 2? Because 0 is easy to calculate. Okay, easy calculation. Because it's always easy to sub 0 rather than a negative number. So we like the number 0. So that's why we can do this. This is not really, it's not really something we need to remember. You can see from the diagram, and it's half relationship between 0 to 2 to -2 to 2. So we can just have 2 lots of the half of the area. That will give me the total area. Okay, next one. Kfx equals to, make the k outside. Everyone know that already. Like integral of 2fx dx. That's just equals to 2 integral of fx dx. Okay, that's something we already know. We can get the 2 out. Well, this next one, we know that as well. If we add or subtract a function, we can antidiff them separately, and we add or subtract between them after that. So we know that one as well. Okay, so the next one, if we add some constant at the back, well, it's not really something we need to say as a property. We can just get that done by ourselves. So you can say it's the integral of fx and then plus the integral of the constant c. Okay, the integral of constant c will be cx. Okay, integral of 2, that becomes 2x. Integral of 4 get 4x. And now we sub, okay, because this one equals to cx integral of a to b. That will be cb minus ca. And that's just a cb minus a. Yeah? Also, you can see this as an area under the curve. So what's a c function looks like? That's y equals to c, or say, let's say that's fx equals to c. Okay, that's fx equals to c. If I talk about the area under the curve in between a to b, that's just a rectangle shape. Okay, that's just a rectangle shape. So this length is b minus a. And this length is just c. So rectangle c times b minus a. Again, it's the same. Okay, it's the same. Okay, next one is important. Next one is a real property. What's that? A to b fx will be equals to negative b over a fx. If you change the terminus, that will be negative of the original. So if it's 1 to 2, then you change it to 2 to 1, the value will be negative of before. So originally say integral of a to b fx dx equals to 3. Then b to a of fx dx, that's equals to negative 3. That's something you need to know. Okay? But now think about that. Same question as before. If I talk about the total area in between a to b, okay, if I'm talking about the total area in between a to b, I have another way to write it now, like the total area equals to, well, a to c fx. That's definitely true. I can plus b to c fx dx. Why? Because c to b is a negative, then b to c must be positive. It's negative of the original. Okay, it's negative of the original. C to b is negative. Then negative c to b must be b to c. That will be positive. So this one will be positive now. Okay, that's another thing we can do. Instead of the subtract a negative area, we can just change the two limits, the upper limits and lower limits, to make it into positive. Okay, it's the same example as before. That belongs to this one. Okay, last one. A to b fx dx can be a to c fx dx plus c to b fx dx. So why is that like that? It's very easy to explain that one. Okay, the last one. I don't know what is c. C can be anything. Okay, c can be anything. I will use positive to represent. So say I want to find the area in between a to b. Get this area. I can just randomly pick a c value, like anywhere of c value. I can say c is here. I can use this area to add this area. That's still the same area in between a to b. So that's why integral a to b of fx dx. C can be anywhere. C can be slide in between a to b. So it can be a to c fx dx plus c to b fx dx. Okay, that's what I will have. Now, let's move to next page. Okay, that's all the property. But I think the only important property is this one. Okay, the only important one is this one. Because that's the real property, like you need to know. All the others, you can calculate that by yourself. You can see it or you can prove it by yourself. It's not really something you need to remember. It's just, you can see that. But only this one is something you need to remember. All the others you can reason in them by yourself. Let's see example 12. Integral of fx between 2 to 6 give you area of m. Integral of gx in between 3 to 5, you have area of p. Find the following in terms of m or p or both. Okay, m or p or both. Well, you can see the first one. I can get the 4 out. 3 to 5 gx dx minus 4 out. 2 to 6 fx dx. You can just get the 4 out. That's the property. And that's 4p minus 4m. Okay, that's 4p minus 4m. I want something expressed in this way or this way, and I can use m and p represent that. Okay, next one. Next one is interesting. What I will have is integral of 4, but like 6 to 2. Integral 6 to 2 of 4 dx minus 2 integral 6 to 2 fx dx. But I don't want 6 to 2. I want 2 to 6. Okay, I want 2 to 6. Okay, what I will have here is 4 bracket 2 minus 6. Okay, that's the rule we have. Cx and the c2 minus c6. So it's 4 times 2 minus 6. And you can see here it's a minus 2 times a minus m. 2 to 6 is a positive m. Now 6 to 2 will be minus of the result. Okay, so this is minus m. Okay, 2 to 6 is positive m, then 6 to 2 will be minus m. So what I have here is minus 16 plus 2m. Minus 16 plus 2m. Okay, 2 to 3 fx plus 3 to 6 fx. Okay, 2 to 3 and then 3 to 6 of the same function. That's just equals to 2 to 6 fx dx. And that's just n. Okay, because this is the c value. Okay, so 2 to 3 and then 3 to 6 is the same as 2 to 6. So it's just the 2 to 6 of fx and you have n. Okay, they are all the easy properties. You can see that immediately. But let's have a look at D. Okay, everyone needs to listen carefully for D. D is one, well, this actually happens in the VC exam 1 year multiple choice. I can't remember what's the exact paper. 2010 or 2011, no, it can't be 2000. It can't be 2011, it's the year of mine. I think it's the 2010 paper. Okay, multiple choice. 20 to 22 something, like about that number. Like one of the question in the multiple choice questions. It's a really hard integral question and appears in a lot of company papers every year. You can see this is one really typical type of questions. What's different in this question is the F to X. Okay, it's the F to X. Have a question. I'm not sure if I can finish that today. If I can't, I'll continue tomorrow. This F to X. Tell me, ignore the 1 to 3 thing. F to X dx. Is that the integral will be F to X? That's my question. Do you think that's true? Do you think lowercase fx to x will integral of that will give you capital to x? Is that true? Yes or no? Or is that right? That's what I want. Why is not correct? Which rule you think it might involve? You can see that it can't be the correct answer because of the 2 is inside. It's a composite function and you need to think about chain rule. Okay, it's not as easy as you just anti-diff the outside function and whatever you have inside you don't care, like you can't do that way. So what you will think about is, tell me, it must have got some relationship between capital F to X, but it's not exactly that. So what I want you to think about now is, okay, first of all, it must relate to that. It's 3 steps, okay, this question. You have that equals to n. Okay, you have that, that's what you know already. Now, integral of fx, you get capital Fx. 2 to 6, that equals to n. So what that means is f6 minus f2 equals to n. Okay, that's from the thing you know already. That's what you get. Second, that's the first thing you think about. Second, what you think about is, what's the relationship between lowercase f to x to capital F to x? The integral must involve capital F to x. But I don't know what the exact form it should looks like. So now, let's diff. Okay, diff what? F to x. I know the anti-diff of that got some connection with that, but I don't know what's the exactly relationship between this and that one. Can you tell me what's the differentiation of this, please? What's the diff of that? What's the diff of f of gx? Well, we should know that. What's the diff of that? What's the diff of f of gx? G dash x, f dash. Yeah, f dash gx. So what's the answer should have for this one? 2 f of 2x. Okay, because anti-diff lowercase f, you get capital F. So you diff capital F, you have lowercase f as well. So when you diff capital F of 2x, you will have 2f of 2x. So by the integral of recognition, anti-differentiation by recognition, you know what? You know anti of 2f of 2x. Dx, you should have capital F to x. Okay, that's something you know. Like plus c, I don't care about that now. Just that's what you will find first. Okay, step 3 is analysis your question. Okay, so okay, we're trying to do that. So, well, first of all, I know I can separate them. Okay, I will deal with the f to x first. And then I will add the integral of 1 to 3 of 3 dx. Well, the plus 3 is really nothing worries me. You can just calculate in the end. It's the f of 2x worries me more. So what I can have here, I don't know what the integral of f to x gives me. But what I know is I can anti-diff 2f of 2x. Therefore, I will times a half in the front. I still make it becomes the same as before. But why I make it into this form? I need that. Okay, that's what I find before. Okay, I know anti-diff that will give me capital F to x. And then I will plus, well, that's easy, 3 times 3 minus 1. That 3 is easy. So what I have here is a half. Anti-diff 2f of 2x, you get capital Fx. Okay, you get capital Fx. 1, 2, 3. Plus, that's a 6. That's a 6. So what I have here is a half of f, that's a 2x. Right, wrong. Capital F2x, not capital Fx. So what I have here is a f6 minus f1. You sub the top function and you sub the bottom function. So what's capital F6 minus, oh, that's a 2, sorry. What's capital F6 minus F2? Go up to the first step, that's the M. Okay, that's the M. F6 minus F2, that's the M. So, what do you have is a half M plus 6. Okay, that's the answer for that. Okay, that's the final answer. It involves 3 steps. You need to see the connections between capital F to X. The integral will be in some form of capital F to X, but I don't know what exact form I should have. So I will div F to X first to see what integral I should have and to make it into that form. So it involves a lot of calculation here and involves a lot of thinking. So it's not an easy question. It can be a 3-mark question if it's not in multiple choice. Okay, so you can see a lot of similar questions in last year practice exam and also in the multiple choice 2010. You can see that as well. Okay, if you have questions, you can think about that tonight and ask me start of next lesson. And I'll show you last year's multiple choice as well, like the even function one.